First of all, I know you've heard this a million times, but I want to add my thanks to all of you for attending this our event. It's even bigger than we anticipated, and we appreciate that all very much. I'm Brian Adler. I'm a professional services architect at RightScale, and I'm going to be joined by Josep Blanquer, who is a senior architect in our engineering department, and talk to you a little bit about what the marketing folks came up with as cloud immortality, architecting for high availability and disaster recovery. But obviously, if you have disaster recovery, you don't have cloud immortality, right? So I prefer we call this maybe application immortality or something like that. So I'll make sure I I'll check the marketing people's work next time they sign me up for a title. So in my role sort of in the professional services organization, I talk to lots and lots of customers from everywhere from, as my boss says, the two guys in the garage with a credit card and a dream, all the way up through our enterprise customers. So we've seen sort of the gamut of what our customers are doing. And we've gotten a lot of best practices, tips and tricks about promoting high availability and disaster recovery scenarios. And then Josep in helping to design what we RightScale, the eat our own dog food or drink your own champagne, which is the one I like a little better, that concept. So how we kind of do it for our own infrastructure as well. So at the end, he'll show quite a few diagrams to kind of drive home some of the points that we're going to talk about. The agenda I kind of want to run through is, first of all, just terminology, and just make sure that we're all using the same words to mean the same things, because sometimes people use a little bit different terms, different words. So the second is takeaways, and those are the takeaways that we hope you guys get out of this, sort of the things that you walk away from here going, okay, that makes sense, or okay, I can apply that, or I'll investigate that further. We'll talk a little bit about designing for failure. To quote, I think it was Werner Vogel's made that comment, everything fails all the time, and you have to be prepared for that. So we're going to talk a little about how you can be better prepared for that eventuality. More terminology on cloud and component definitions, what we mean by a cloud and what we mean by the components that build up that cloud. We'll look at some high availability and disaster recovery. That's I should have put that in the terminology slide, but it is in there. But anyway, so HANDR, high availability and disaster recovery. Some sort of checklist that we run through with our customers and also internally, and also some best practices that we can recommend. And then, like I said, Josep will give you guys a full suite of architecture diagrams, kind of show you sort of starting from scratch and building your way up. And then obviously some conclusions and QA at the end. So I think Josep and I haven't done this together yet, but I think we should have time. So I don't think we'll be pressed for time. So if folks have questions, feel free. Obviously, we can answer whatever you guys need at the end as well. So quick on terminology, just a couple things I want to bang through real quick. Fault tolerance, I'll read the definition and we'll talk a bit more about it. But designs that incorporate redundancy and replication to enable systems to continue operating properly, perhaps at a greater level if one or more components fails. Basically what that means is if something breaks, you're still up and running. You might not be running as good as you were, but you're still up and running, right? That's a fault-tolerant system. It can tolerate a or multiple faults. HA, high availability. Fault-tolerant systems are basically, that's their scorecard, right? Their high availability, their availability is how these fault-tolerant systems are rated, if you will. And you always hear about the nines, right? So just put up a couple examples here. 3 nines, 5 nines, et cetera, right? 3 nines, you have 8.76 hours of downtime a year. 5 nines, you can only have 5.26 minutes of downtime. Now, the very key point of this is that it's planned and unplanned. So granted, unplanned is one thing, but planned, if you have to take your system down to do upgrades or whatever, that counts against your availability score. As any of the RightScale users, I know we have some folks out there that are new to RightScale, but any of our RightScale users know we do a pretty rapid release cycle. So usually every 6 to 8 weeks, we have a little bit of downtime as we upgrade the system. And Josep and his team are working on compartmentalizing and modularizing all of our infrastructure to help minimize our downtime and therefore increase our availability. And then lastly, disaster recovery, or DR. The process, policies, and procedures relating to restoring critical systems after a catastrophic event. Basically, something really bad happens. How long does it take you to get yourself back up and running to a functional level? All right, that's what DR is all about. Generally, that involves moving your entire infrastructure or your entire application from one infrastructure provider to another, and we'll talk a little bit more about that as we get deeper into the presentation. Okay, so the takeaways, the things that we're hoping that you guys will get out of this. We're going to introduce you to some architectural options for designing these HA fault-tolerant applications and as well as DR scenarios. The best practices that we've accumulated over the last 4 or 5 years for implementing these architectural options. And then we'll talk about the multi-AZ, multi-region, and multi-cloud, the architectural options you have in each of those environments, as well as the pros and cons. A lot of folks come to us thinking that they really, really want a multi-region or multi-cloud environment. And while it's totally doable, once they get into the sort of the devil's in the details, and once they get into those details, sometimes they back off a little bit about that. And Josep will talk more about that when he gets to the pretty pictures, I promise, at the end. Designing for failure. Large-scale failures in the cloud are rare, but they do happen, right? That's become more and more obvious in the last 8 months, right? April and May was sort of a little bit of a black eye for the cloud, but in a way it was a good thing, right? Some of the outages, and I'll give Amazon all the credit in the world, they've done such a phenomenal job that a lot of people took a lot of things for granted and just assumed that, hey, everything's always going to work. Well, these cloud outages showed you that that's not always the case, right? So you need to be prepared for that. And ultimately, you or whoever owns your application is ultimately responsible for that uptime, right? For that availability and the recoverability of your application. Your infrastructure provider can provide you an SLA and they're going to do their best to meet that SLA, but there's no guarantee they will, right? If they don't, they refund you a month of your service fee or whatever it may be, right? So ultimately, if you want to make sure that you're up all the time, that's your ultimate responsibility, okay? And as always, it's always a balance of complexity and cost and risk and all that kind of stuff, right? How complex a solution you're willing to tolerate, and therefore how costly, versus the risk you're trying to mitigate. If something's really unlikely to happen and it costs a lot to mitigate against it, maybe you don't care. If something's pretty likely, you probably want to put in the time and effort and the money and whatever it takes to help you recover in that eventuality. The nice thing, sort of the positive on this slide, that the cloud infrastructure and the infrastructure as a service vendors have made DR and HA really remarkably affordable versus everything in the past, right? Where else have you been able to do things like multi-server, multi-availability zone, multi-region, and multi-cloud, spin these things up in just a matter of minutes, right? And we've always heard the stories before about procuring hardware and it takes months and 14 different signatures and all that other kind of stuff, right? So the options that we have now are phenomenal compared to just a few years ago. A couple more definitions before we get into sort of some of the best practices as well, all right? What do we mean by cloud? All right, and you heard it this morning. I think it was Torsten's point that Michael was driving home, is that true clouds are API driven, right? And we couldn't agree more, right? A cloud is a physical data center, some sort of physical data center entity behind an API endpoint. It's an API that you hit to access these resources that live behind it, okay? What does that really mean? Well, AWS is not a cloud, right? EC2 is not a cloud. Eucalyptus, Cloud.com, OpenStack, those are not clouds. Those are cloud enablement technologies, but they're not clouds, right? When you get down to the API endpoint with that physical infrastructure behind it, like EC2 US East or the EC2 US West Oregon that they released last night, right? Or Rackspace or My Private Cloud, those are clouds, okay? And an important distinction here is an AZ or an availability zone is not a cloud, but it is part of one, right? And that'll factor in when we start to talk about some of these HA in particular and DR scenarios in the architecture diagrams that you'll see in a little bit. So sort of the takeaway, think of a cloud as a resource pool, right? Networking, storage, compute resources behind an API. You can hit that API and get access to the stuff that lives behind it, all right, in that data center. So a little bit of pictures around that. So regions and availability zones. This is sort of a generified version of it, right? But you have your cloud infrastructure provider, and we have 3 different clouds here. Now, while they might all be from the same cloud infrastructure provider, they're not one cloud. They really are 3 different and distinct clouds. You have Cloud Region 1, Cloud/Region 2, as well as number 3. They can have a different number of availability zones within them, but they are distinct clouds, all right? A couple features to note. Zones within a region share a local area network, okay? So therefore they have high bandwidth, low latency, and private IP access. So for example, all of the servers that live in Region 3, Zone 1 through Zone D, they all live on the same 10.x network. So if you're in Zone 1A, you can hit a server in Zone 1D on that same 10.x network, okay? And that's all internal, if you will, to that cloud provider. Obviously, this is sort of an AWS type example, but it holds for other infrastructure providers as well. Now, typically within an AZ, so if you're going server in A to server in A, there's no cost on the bandwidth. If you cross that AZ boundary, you go from A to B or A to D, there's usually a nominal charge. It's currently like a penny a gigabyte in AWS. But again, that's still very low latency and very high bandwidth and does not need to traverse the public internet. Regions, however, are islands, okay, and they share no resources. So if you do go from Region 1 to Region 2, you have to traverse the public internet, and you're subject to all the potential pitfalls of that, right? Security, latency, downed hops, all that other kind of stuff that might affect that, okay? And then, sorry, I skipped over the middle bullet, but that's sort of been talked about this morning as well, is that they use these zones utilize separate power resources and are physically segregated. They're different buildings as well. So if an AZ goes down, it should not affect another AZ, right? Okay, multi-cloud pain points and how do we overcome them? This is sort of what they are, and the next slide is a little bit about how to get over them. But APIs differ, right? The EC2 API is dramatically different than the Rackspace API, right? And that's caused us a lot of pain, but we've gotten through that pain. There's different sets of available resources. Not all cloud providers provide the same set of tools, right? There's different formats and encodings and different versions, etc. So there's a gamut of choices out there. The menu is different from each of these providers. And similarly, the abstractions and the features differ, right? The network architectures can be different. There might be VLANs, some have security groups, some don't, some use IP tables, whatever it may be, right? So again, how they implement these abstractions can differ as well. Storage architectures, some clouds provide attachable block storage, others don't. You only get local disk, that kind of thing. So there's lots and lots of features that are different, and the abstractions and how they're implemented. So each cloud is unique in some, many, or all of these respects, with different access mechanisms and varying functionalities provided by the managed resources. Basically saying that all these things are different, and how you're going to treat them may need to be different. Now, fortunately, a little RightScale plug, obviously the MCI concept and the server template concept abstracts a lot of this from you, but not all of it, okay? How do we get over these obstacles? Well, when you design your solutions, we recommend you design using generic concepts. I need durable storage. Don't say I need an EBS volume. Say I need durable storage. And then you use whatever the cloud provides to give you durable storage. If you're in EC2, that would be EBS volumes potentially, right? So use these generic concepts and then use cloud specifics when it comes time to actually deploy. Have tools in place that translate your concepts to cloud-specific ones, right? So for example, if you're in one cloud and you're a CentOS lover and you're running on CentOS and you have your install my Apache web server, so you've got some scripts or recipes that install, HTTPD, and you have in your failover environment and your disaster recovery cloud, they don't provide CentOS. You only have Ubuntu. Well, that would require installing, Apache 2 instead of HTTPD. So you need to have some sort of way of automating that and knowing which resource and which provider you need to use in these different environments. And then you have to worry about how to share those resources across clouds. And Josep will get on a little bit of that when he talks about the multi-cloud scenario. That's where it gets the most complicated and potentially the most costly as well. Okay, some checklists and best practices. This is sort of something we talk to a lot of our customers about that come to us and ask us about high availability and disaster recovery. First thing we always recommend is determine who owns the architecture, the DR process, and the testing. They're probably not the same group, and they probably shouldn't be the same group, right? The same people that design the architecture shouldn't be the ones that's testing it, because they know how it's supposed to work. They don't know the stupid things that no one would ever try. Well, give it to someone who doesn't know those things, because they're going to try it, and they're going to find where the brittle points are, right? You want to develop some expertise in-house on DR and HA, and or get outside help, and no little RightScale PS plug that I work for, but hey, that's the kind of thing we can help with, and others as well. You want to conduct a risk assessment for each application, all right? Find where your weak points in your application are, right? The old every chain has a weakest link analogy or whatever it may be, right? Find where that weak link is in your application and do what you can to mitigate around it, okay? You really need to assess each and every one of your applications. Specify your RTO and your RPO. Usually those are kind of in direct contrast. The higher your RTO is, the less your RPO is, and vice versa, right? So you really need to think about how much data can I afford to lose and how long can I be down, and try to find a solution and architect around a solution that'll provide you metrics that get you to the metrics you need for the RTO and the RPO. Design for failure starting with the application architecture. This will help drive the infrastructure architecture. You can have the greatest infrastructure architecture in the world. You can have a highly scalable database. You can have it all set up. You've got sharding in place. If you have single-threaded access to the database, you don't have really HA, right? You've got this bottleneck there, right? And that's an application issue. Make sure your application can take advantage of this great infrastructure that you're designing. Implement HA best practices, balancing cost, complexity, and risk. That's always the trade-off, right? Like I said earlier, how risky is something? Okay, if it's not very risky and it's, if it's not likely to happen and it's very, very expensive, I might not want to worry about that, okay? If it's very likely to happen, I probably should worry about it regardless of the cost, right? It's like homeowners or car insurance, right? You're paying for something you hope you don't need, right? And always, we recommend, and again, the MCI concept and the server template concept that you may be familiar with obviously help with the automate infrastructure, right? You want to have this automation in process so that if a server goes down, you can spin up another server that looks just like it in an automated fashion, right? You don't want to have to log in and do any dinking around, etc., right? So that automation is key. You want to document those operational processes and the automations, right? This isn't going to fail 10 a.m. on a Wednesday when you've had your cup of coffee, right? This is going to fail at 2 a.m. on a Sunday when you're very groggy, you don't know what's going on. So you want to have a document you can refer to and know exactly what you need to get through that recovery process, right? And then you want to test it, and you want to test it again and again and again, and make sure that you found every single use case that you can, all right? And then to borrow a phrase from our friends at Netflix, you know, release the chaos monkey, right? They have this concept of chaos monkey, which is an automated process that goes around and randomly kills stuff. And they do that on purpose to make sure that they can survive any but survive any potential issue that came up, right? So you should have your own chaos monkey, either automated or manual. You know, hire somebody to go out and kick out every power cord and spill coffee on the keyboard and big red button that says don't push, have them push it, right? Because if they don't, someone will. One of your customers will. So you'd rather find those problems ahead of time before they become problems that public sees. Okay? So some general HA best practices real quick before we hand it over to Josep. So some of these are obvious, some of them maybe not quite so much, but obviously avoid single points of failure, right? If you have a single point of failure, by definition, you do not have a highly available system, right? We recommend, and this is something in PS when I may have talked to some of you folks on the phone, is that whenever we recommend a solution, either that we're building for you or we're recommending how you to build, we always talk about placing at least two of each of these components in different availability zones, right? Spread your load, spread your risk, okay? If you happen to lose an AZ, and it has happened, you haven't lost all your eggs aren't in one basket, right? Spread them across all the baskets that your provider provides to you. This next one is a budget constraint. It is a best practice. It's not always something that's affordable, but we recommend you maintain sufficient capacity to absorb availability zone and cloud failures. For example, some of our customers run enough infrastructure such that if an entire availability zone was to die, they had enough running infrastructure to handle that load. Now obviously that means a lot of their servers are running highly underutilized and they're paying for that, but again, a budget constraint. If they lost an AZ, they don't need to spin up more servers. They've got enough to handle that load, okay? Reserved instances can help a lot here, okay? The nice thing about reserved instances is that they guarantee you capacity. So let's say that you have reserved instances in US West and you're running your entire infrastructure in US East, and US East goes down. Everybody's going to scramble to fire up servers in US West, and it's going to be a free-for-all, right? If you have those reserved instances, you can take your sweet time in getting over there, because when it comes time to fire up your servers, you know that they're going to be there. Again, you paid for that. It's an insurance policy that you're hoping you're not going to need, but again, you know, in a perfect world, best practices, budget notwithstanding, that's something that's definitely recommended.
What is AZ?
Availability zone. Availability zone. We recommend you replicate data across the AZs. That's generally not too hard, and back up or replicate across clouds and regions, and that's the harder part, and that's why I'll leave that for Josep to talk about. We set up monitoring, alerts, and operations to identify and automate problem resolution or the failover process. Basically that means set up monitoring and alerts to find problems before they become problems, right? Generally servers don't just die. It does happen, but generally they don't die. They start to show signs of death before they die, right? So look for those signs of death and have some sort of alerts in place to alert you that, hey, something's going wrong here. So you can go ahead, log in, make whatever changes you need to make, okay? So again, try to find problems before they become major problems. And then lastly, design stateless applications for that are resilient to reboot and relaunch. Not always possible. I know a lot of applications rely on session affinity and session stickiness, but if possible, right, have an application that doesn't need that. So if a server was to die or reboot or whatever, the end user would not necessarily be affected, okay? They might need to, if it's a sticky session, they may need to re-log in or something like that, but it's great if you can avoid that, okay? Again, general best practices, they might not all apply to your particular application or to your particular budget. Okay? So yeah, any questions for myself before we hand it off to Josep? We'll have plenty of time for questions at the end as well. Cool.
No questions. Oh, one question?
I have a question.
Okay.
Angela.
So, Brian, you referenced MCIs, which I think are multi-cloud images, and I was wondering if you could explain what exactly they do when you're building a multi-cloud deployment.
I'll be glad to answer that if you promise not to name my next presentation Cloud Immortality. All right. I know. So thank you. I did mention, I did use an acronym, and I apologize for not defining that one ahead of time. MCI is multi-cloud image, and a multi-cloud image, for those of you that aren't familiar with it, is the RightScale concept that we have a write image that runs in a particular region. So for example, we have a CentOS 5.4 image that run on CentOS 5.4 on a 64-bit platform that runs in US East. That same image will not run in US West, but we do have an equivalent, a very similar image that will. We have the concept of an MCI, which basically wraps all those together so that no matter which region you decide to deploy in, you can use the same server template which is sitting on top of this MCI. The server template is smart enough to know which of those write images that make up that MCI it should use to run in that particular region. So again, that sort of abstracts you from having to worry about, well, crud, I'm just going to go into this, APAC region and I don't have an image for that. Don't worry about it. We've got it covered if you're using that MCI concept. Okay? Yeah?
Does that extend into the private cloud stuff?
Does that extend? Yes, the MCIs will cover the private cloud as well. So you can have that same server template that could launch in all the regions of AWS, in rack space as well as in your cloud.com environment, your OpenStack environment, your Eucalyptus environment, whatever it may be. And that MCI may have 10 images, 10 write images living underneath it. And regardless of where you launch, it will choose the right one. Correct, yep.
Let's see, what I want to do in this second part of the presentation is let's try to keep it a little more open and ask questions as you see fit. I just have some slides that show, basically what I want to show is, let's start with a typical application, 3-tier in your little cloud, and let's start moving things out of that cloud and see what are the challenges that are involved in doing that. So if you think of things in the middle that I may not cover, just let's talk about them. Okay, so let's start with that simple example. So you have your little cloud, and you want to deploy your typical 3-tier architecture. You want to have your load balancers, maybe very simple couple load balancers, round-robin DNS, so that if one fails, the other one is still serving traffic. You have some sort of application server layer, maybe PHP, maybe Rails, whatever you have. And then the third tier is a typical master-slave database. So even within one cloud, there's a lot of things that you actually can do for HA purposes. So as Brian is saying, one of the important things is to leverage the availability zones. So what do you want to do? The first thing you want to do there is make sure that you don't put the load balancers in the same zone. Because if that zone goes down, your load balancers goes down, everything, it doesn't matter. So that's one way to spread it. Obviously, you want to do the same thing with your app servers. Have some app servers in one zone, some app servers in the other zone, right? At least you have some power if one of the zones goes down. Like in the master slave, it's a little more tricky, but obviously you want to put them in different zones. And in this simple case, if zone 1 goes down, you'll lose the master, you'll have to do some sort of promotion of the slave. So there's a little bit of a blip, perhaps, but your application is up and running in no time. Okay, so that's one interesting thing. So the other thing within one cloud, within one single cloud that you have to have in mind also is the security aspect of it. And things like security groups or firewall rules are also important in designing this piece of the application. Because for example, in here, what do you want? You want only the load balancers to really be open to the world. Nobody else should be able to talk to any of the other parts of the application. So that's you can think of that's one tier that is open to, say, port 80 or port 443 if you do SSL, right? And then you also want to configure the app servers only being reachable from the load balancers. And things like security groups allow you to say so, right? I launch these application servers in a particular security group that have a friendship relationship with resources in this other security group. And the same thing happens for here, right? Only the app servers should be able to talk to the databases. So most clouds give you availability zones and security groups / network rules. So that in its own is a huge advantage, because within a single cloud you can actually achieve a fair good of availability. Okay, so obviously you have to think about these things, the zoning, the security, and then everything else that goes on top, right? You need to think about monitoring these things well, having the alerts when something happens, that they wake up the right people, every automation that triggers from these alerts, any API calls, anything that that makes sure that everything is up and running all the time. Let's assume that this little application that we have here, we want to start moving things to another cloud. So there's different reasons for doing that. One could be just simply bursting, say, application power into another cloud. right? Another could be just having HR to another cloud. So the thing that you do is the same. So let's assume that we want to, suddenly our little cloud is small and we need more application power. We want to burst out into, say, a public cloud. What we want to do basically is start launching application servers in the other cloud and have a way to absorb the traffic that you need. So what do you do when you want to do that? From a RightScale perspective, you would probably want to set up something that we call a server array. It's a concept that says, I have this server template that tells me how to configure my application server. Maybe it's a PHP stack. Okay? So I'm going to say, this server array is launching PHP stack servers. And I'm going to want you, RightScale, to launch as many as you need, depending on the CPU that all application servers, these and those, actually are experiencing. Right? So you have this metric, which could be CPU, could be response time, whatever you want to feed into this application. And this server array will shrink or grow the array. Great. So that's very easy to do within RightScale. But there's an interesting thing that you need to do here. You need to connect these application servers to both the load balancers, so they can get traffic, and to the database. So in here, like we said before, it's kind of easy because you can have these security groups in terms of, you can say this is trusted with these ones. So it's sort of within cloud, you don't go through the internet. So it's kind of much easier. But in this case, if you want to do this, the first thing you need to know is, how are these guys going to know about those load balancers? How do I reach these load balancers to start sending me traffic? Well, there's many, many ways in which you can do that. Simple ways, as in, somehow I know the IPs of the load balancers, and I have an SSH key that allows me to contact them and say, hey, I'm here, send me things. Another way, which is the common way that we do things, is using RightNet. RightNet is basically an infrastructure, networking, secure networking infrastructure that allows you to say things like, I'm going to send a message to the load balancers to let them know that I'm here. That's another way. That's all within RightScale, and it's all encrypted, basically, internally in the system. You can do other things like, every app server that comes up may register into a central repository announcing themselves, and then the load balancers periodically may go and see, oh, there's new guys, so let me send them traffic. So there's many ways in which you can do that.
I was hoping that those things that, is something RightScale can do for the application rather than the application developers has to themselves, right?
Right. We do that, but it kind of depends on the application. So you can actually reuse many of the things that we have in the templates to do that yourself.
So basically, you're saying that you probably already have the templates for the typical, say, PHP or
we do.
Django, this kind of thing.
Absolutely.
All right. Okay.
And
that
even if you have some sort of stack that is not supported with what we have, I don't know what it would be, but something that's not PHP, Rails, and all these things, you could take some of the recipes on the templates that we have and apply them in your own templates. So you could take the piece in which it says, for example, a typical thing would be when the any app server comes up, there's a little recipe or script that will tag themselves as, I am an app server. So, every app server that is running, they're tagged with some text, app server. So that's very easy to do. You can reuse that. And you have other recipes in which the load balancers, for example, you can make them execute certain things, and the load balancers then will go and say, all right, I know that I'm serving to these particular app servers. Let me see which servers in this deployment are tagged as app servers, and I know that those are the servers that I have to send traffic to, for example. So all these things you can reuse very easily for your app. The first problem was to find out between the load balancers and the app servers. The second problem is that will be the inverse in terms of saying, oh, these app servers need to know what the master database is. And you can use similar setups in that situation. You can use even trivial things like DNS, right? The master hasn't changed. You just look up the DNS and you connect. But we have this thing here in the middle that we didn't have before. Anything that you want to do across these two clouds has to go through the public internet. So you probably care about that, and you don't want to start sending things that you don't want other people to see. So you have to worry about access control, and encryption here, right? Because in the same way that I explained that security groups within the cloud allow you to say things like, this tier is only allowed to talk to this database, you cannot say that. You cannot extend that to these application servers. Those are in a different cloud. Could be a different provider, for all we know, right? So you need something equivalent that helps you with that. You need to have a way to allow these particular guys to have access to this master database. You can do that by your firewall rules, and RightScale may help in the future by having some higher level abstractions for it, but in a way you have to solve that problem. And on top of it, you probably want to encrypt whatever you send to. So the next thing we want to do probably is to see if we can have a better availability in terms of the database. So the typical thing that you would do within the cloud is to have one or more slaves replicating directly from your master, right? So if you want to extend that into the public cloud, it would be as simple as launching a slave machine here in the same way that you would launch it in the other cloud and having it start replicating. Okay, well at that point, if this thing goes away, we're not up, but it could be very simple for us to really launch a load balancer and connect everything and continue working, right? It's an interesting thing here that happens because I said you launch, well, you have the same problems with encryption and everything that I talked about before, but where's the data, right? I can launch a server here and it's going to start replicating, but if my database is 1 terabyte, the data is not going to poof appear, right? So we're sort of spoiled by thinking that within a single cloud, things like Amazon, you can basically restore a 1 terabyte of data from a snapshot that you've taken before, right? So we usually, within a single cloud, you have snapshots from the volumes that you have the databases, and the slave can recover the whole data of a snapshot in a very, very fast way, and then start replicating after that. It's going to be slow at the beginning because it's copy and write, but it's easy. You launch it, mount this volume, and start replicating. But in here, I cannot create a volume out of a snapshot in this cloud. I don't know what that cloud is. This is completely different. So this is where the thing kind of gets a little muddy, because if you really want true HA or true DR, so to speak, across 2 different clouds that could be completely different in terms of even providers, you need to have this data somewhere that is accessible from both sides. And there's many ways to think about how to architect this. Simple things like global storage. Maybe you can put things into S3 or cloud files so that both slaves over here and the slaves over here can draw from. That's a simple one. Depending on the size of the database, that may be okay. If you have 1 terabyte of data, you're going to have to do a little more work to get that working fast. You could do live replication with rsync. So for example, in this case, we could have said, launch a slave, set up the right tunnel so that you can rsync the basic database, say, from another slave, as to not to bother the master. Once I've rsynced, if I know exactly at what point I have started rsyncing, then I can continue replicating after that. So that's one way to bring the data in, instead of bringing it from a global store. Or maybe, if you can, depending on what pieces of the application, maybe you don't even want to have a relational database. Maybe you have to think about the NoSQL database that natively it may actually replicate in an HA fashion across the 2 different clouds. Sometimes you can, sometimes you cannot.
Hey, Seth, do you have a recommended methodology for that? Like for, say, MySQL or something? Does RightScale have like a tech paper on that?
MySQL versus NoSQL, you mean?
No, for actually doing the replication across clouds.
We don't have a recommended thing. What I would think is that an easy way to start with, what I would probably think of doing is restoring a slave here from a snapshot before, without replicating, just simply getting that disk into a machine, or syncing that disk into this guy, if you use our backups, the data in the snapshot tells you exactly where in the replication bin log sequence you need to start latching onto. So as soon as you have our synced over here, you just have to configure this guy to replicate from the master. So that would be an easy way to do that. Beyond that, kind of depends. It really depends on the size. It's like, you know, we get into this application-specific stuff.
So basically, you use rsync to sort of bootstrap the process.
It's about the bootstrapping, correct. And you have to bootstrap and know exactly where you are, so you start replicating exactly, in MySQL at least, right? Right. Yeah.
Let me just add one thing to what Josep said as well. What we've done in professional services for ourselves as well as for customers, mostly in a proof of concept method, is we did two different styles here. One is sort of the one that Josep's talking about, where we took a snapshot, we did it across AWS regions, AWS US East to AWS US West. So we had the same concept of EBS volumes, et cetera, but obviously we couldn't share resources. So what we did is we took a snapshot of the master database. What we then did is restored on a T1 micro from that snapshot and attached a volume to it, so it's there running. We did the same thing over here with a blank volume. We did that rsync across. We then took a snapshot on this side, and we were able to launch our slave using that snapshot where it started, and then as Josep said, using the bin logs, it was able to catch up when it started to replicate. So that was one method that we used. And the second method that we used was where we used, instead of using EBS snapshots, we used LVM snapshots. And we're able to take those LVM snapshots, push them to S3, and then use that as the feed, if you will, to the slave on the other side. Okay. Yep.
I think there was a question over there. You have a question?
What have you heard of people using RDS? Have you heard good stories or horror stories or?
You've heard much more than me, so.
We have it. So the answer is well, the sort of the answer that we give, and we get a question about when in professional services when we have folks coming on board that want to use a database solution, we get questions about RDS quite a bit. And obviously the benefits to RDS is it's super easy to set up, right? And you don't need a DBA essentially, right? And they have the multi-AZ and it does the replication for you and all these other kinds of things. That being said, there are some cons to it as well, and it all depends on your pain points and where you're comfortable, where you're not comfortable, etc. But what we've seen with RDS is that, for example, in the April 21st outage, which was basically EBS driven, 47% of RDS instances were affected because they use EBS and they're across multiple AZs, and that was exactly the problem that was encountered that day. So granted, that might be an isolated case, but that was many more of our customers were affected on a percentage basis that were using RDS than were not. RDS is a black box, right? It's a database appliance. You say SQL to it and you get SQL back, right? You can't do some of the super privileges, which I know Josep knows a lot more about the database stuff than I do, but you can't become the super user, if you will, in the database and do some of the things that you want to do otherwise. If you ever want to get off of RDS, there's no way to replicate from it, right? You can't have a slave replicating from an RDS instance. What you got to do is shut your thing down, dump the data out using a MySQL, dump to a running instance somewhere, and then do a MySQL import elsewhere. We had one customer that ended up being down for 22 hours while they migrated off RDS. So, but maybe you guys are totally it's a vendor lock-in thing. More kudos to Amazon again. They found a way to keep people on there, right? And if that's okay with you, that's great. I'm just saying there's pros and cons to everything.
Why did they migrate off of RDS?
What's that?
Why did they take the pain of...
Because they weren't happy with the performance, and that's another common request and common complaint that we get, I should say, is that the performance of RDS is not that acceptable generally.
Isn't it the same though? I mean, it's still a MySQL running on... It
still is, but again, it's a multi-tenant, essentially. You are dependent on your neighbors, right? And you don't know how hard your neighbors are banging on your disk, that kind of thing. Now, that's true. That is very similar in the MySQL solution as well. But the way that, I don't know the details behind how they've implemented RDS, but we have seen, we do a bunch of benchmarks. We did load balancing benchmarks. We published a white paper on that. We wanted to publish one on EBS performance. We couldn't. The numbers were all over the place. And we got different data based on day 1 versus day 2. 5 minutes apart, we got different data. So what we've seen is that performance varies even more so in RDS. And the reason they wanted to get off of that was 2 reasons. One is that they saw this random performance, and they weren't able to get access to tuning that they really wanted to, right? You can't really get to your myCNF file and dink with all the things you want to. They only recently gave you the ability to look at slow query logs, and you have to do that through their interface and stuff like that. So the tuning aspect, but again, for customers The two guys in the garage with a credit card and a dream that come to us that don't have a DBA, that's what they want, right? I don't know about databases, I don't want to know about databases, and that's fine. For our more enterprisey type customers that want that fine-grained control, RDS typically is not a solution that they go with.
Is there a question somewhere there? Yeah.
Yeah, there's a question about your first slide. This is going back to the HA. You were talking about round robin on the load balancers, and everything looks pretty good as far as, you know, high availability. The only problem that I think we would have if we were to do round robin with the load balancers is that if one of the load balancers goes down, then you have a split brain DNS, pretty much. And if you don't have a very low TTL, you're going to be sending traffic to a dead load balancer.
So, yes and no. So, yes, except that 99% of the browsers are smart to avoid that. They know that they have to send it to the other side, basically. So if you had a completely dumb browser, they will be trying that guy that is down every 2 requests or whatever. But they're very good at detecting these things. So the bottom line is that it hasn't happened in 4 years. I think we had one load balancer go down for an hour, like 4 years ago, and not even knowing. The last piece that I wanted to show here is that, well, we're not quite done yet, right? Part of what we want to probably do is just say, I'm going to move this guy over here in case the whole cloud goes down. So that's as easy as, again, launching this server over here, and then having a way for all the app servers here to know about this other guy, and the app servers here to know about this guy. If you use like tags in RightScale, nothing really changes, right? Because say the load balancers will go and see which servers have the app server tag in my deployment, and that's how I get my list, right? So it doesn't really matter if they're running in this cloud or in the other cloud. So that's where RightScale will help you. That's one of the things that RightScale will help you in abstracting out. So when we get into this situation, basically we're almost full HA except the database, right? Because if all this goes down, we just need to promote this slave to the master, so with whatever glitch that supposes, in your infrastructure. But other than that, it's pretty good. And the interesting thing, from the RightScale dashboard, you don't see these boundaries. From the RightScale dashboard, you'll see 2 boxes that are with server template load balancers in your deployment, and then several app servers, or maybe 1 server array for a particular cloud, and then some master-slave databases in one deployment. If you look at some columns, you'll see, oh, this one is Amazon, this one is my Eucalyptus cloud, this one is whatever, but they're servers, right, that you configure them in the same way. So if you have to clone that server over here, if you had a server over here and launch it over there, you clone it, you change the cloud, and you launch it. And if the templates support the MCI constructs that we talked about, you don't have to change anything. That's kind of the power of this abstraction level. Obviously, not everything is abstracted, but you get the feel of this thing. So I think I just have a conclusion slide, so maybe I go over really quickly, and we get some more questions. Takeaways. Be pessimistic. Always design for failure. Think worst case. That's the best thing you can do to begin with, right? You've heard this 100 times. Well, this is 101, because it is important. Everything will go down, and always trade off between the levels of resiliency that you need and the cost. Because you don't want 9 nines if that's going to take 2 years of development time. That doesn't make any sense, right? So you have to see how much you can get with the amount of cost that you want to put into it, right? Don't try to make something totally immortal if that's going to ruin your company budget. Another thing that I think is important is embrace the cloud mentality. It's designing, from an architecture perspective, designing for the cloud is really different from what you might be used in a normal data center scenario. So embrace that. Embrace the fact that you can launch 200 servers in 2 minutes and tear them down 20 minutes later for the test. Embrace the fact that you can launch the same sets of server templates for your developers than what you do for your QA and what you end up developing in production. It's the same thing. You may launch them in different accounts, but it's the same thing. So think in those building block terms and reuse them across your different life cycles in development. Automate every single last detail. That's also sort of very important. So be pessimistic, automate. That's the key tenets there for the cloud. Another important thing that I think it's worth mentioning is that try to reuse everything that other people do, like open source software, systems, clouds, frameworks, but not everything may necessarily fit what you do. If you're very small, most likely you'll get tools that will work for you. But as you grow, there's a lot of differences, a lot of nuances that it may not work for you. So if that gets to the case, don't customize it. Don't develop things that are not in your core competencies. But if you get to the point that if something doesn't work, just change it. And if it's open source, contribute it back. Don't be afraid of doing that, especially in the cloud. And last but not least, take it easy. Just start designing some HA within your cloud, right? Like when we started here. Make sure that you have the different zones, the security, the DR within the cloud, and then maybe start expanding to different clouds, because there's a big change between remaining within cloud and bursting out of your cloud. So just make sure that you crawl first and you have everything well understood within the cloud, and then start expanding that into different pieces that you need to. So I think that's also important. I would say that probably you may want to start with the HA within one cloud using multiple availability zones. Then maybe you want to start experimenting with some DR mechanisms, maybe the database, you have a copy somewhere else. And then when everything that works well, then you can start really moving processing and everything across different clouds. So that's what I would probably suggest. And that's all I have in here.